Hello everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is number of laser beams in a bank. Now this problem is marked as medium, but I would say it's a fairly easy problem to solve, and let us see how. So in this problem, the given input is a bank which is an array of strings. There are multiple strings, but all these strings contains only two characters, either 0 or 1. Now every string represents a row and there are multiple rows, right? So basically we have a bank and we have rows, which is like every row will contain some security cameras. Now every row has some blocks, right? These blocks are the characters of your strings. Every string which you have will contain either 0 or 1, right? So when we say 0, then that particular row and in that particular block there is no security camera. And when we say it is a 1, it means that in that particular row, the first row and the second block, we have a security camera. So every one is representing a security camera, right? Now the question says that there are laser beams. There are some laser beams which are between the security cameras, or I would say the security device. So we have a security device here and we have a security device here, right? In the first row and in the third row. So there is a laser beam between them. So the question says that there will be a laser beam between any two security device, like this is 1 and this is 2. There will be a laser beam if they are in different row, like we have this row and we have this particular row. So there will be a laser beam between them if there are no other security device between them. Like there should be no row in which there should be a security device and that row should be in between. For example, if this is a security device and this is a security device, so there will not be a laser beam from this particular device to this particular device because there is another security camera between them. There is a row, the third row I would say, which contains security devices, but we have another row, the second row, which doesn't contain any security device. So that is why the security device at the first row and the third row, they have a laser beam between them. So simple thing to understand here is we have many security devices in different rows. We have to find how many laser beams are there total. And how do we find any laser beam? If we have a security device in any row, let us say row number I, and we have some other security device in any other row, let us say row number J, then those security device will contain a laser beam between them if there are no security device between them. So the natural way to solve it is we can say that this is our current row. Let us say this is our current row, right? And the question also says that the laser beams are independent of each other. So if this is a device, it will have a laser beam with this particular device and this particular device as well. So this particular element will have two laser beams. This is the first one and this is the second one. Similarly, this one will have two laser beams. This is the first one, this is the second one. So the only condition is the security device should be in different rows and there should be no more security device between them. If there are no security device between them, then they will have a laser beam between them. So count the laser beams. So the natural way to solve it is we can just go through each row, right? Let's go through the last row. Let's start from the last row. This is our last row, right? It has one security device, right? Of course, this one security device will have a laser beam with some other row, right? So let's try the previous one. So let me actually draw this. So let us say this is our current data, current row, and this is our previous row, which we are going to see. So it contains one device, the previous row contains two devices. So naturally, there will be two laser beams between them. This is the first and this is the second. Basically, the count of security devices in this particular row, the previous row, and the number of or the count of security device in the current row. 2 multiplied by 1, we have two laser beams. This is 1, this is 2, right? So let me count it. We have 2, right? Once we have processed this particular row, we can move to the previous one. Now this row is done, right? There will not be more laser beams counting coming from this particular row security device because we have started from the last, right? Now let's assume that this is our last, okay? So in that case, let me move our pointers. These are our pointers. So let me move it above. So what's going to happen is this is our current row now. It contains two security device and now this is going to have more laser beams with the previous row security device. But you can say we have no security devices in this particular row. So at this point, we can assume that this row doesn't even exist. Let's not even try to process this row because it is not containing any security device and it is also not going to block the laser beams between two security device in different rows, right? So in that case, let's keep this as our current row, but we can move the previous row pointer, take it and move it above. Now this is our current row, right? Still this is our current row. It has 2 security device and the previous row has 3 security device, right? So again the same formula, 2 multiplied by 3, it is going to be 6. So there is going to be 6 laser beams between elements or the security device of these rows. This is the current row, this is the previous row, right? Because we have this is 1, right? So it is going to have 1, 2 and 3. 3 with the 3 devices in the previous row, and the second device will also have 1, 2, 3. 3 with the previous row security devices. So in total 6, right? So we got 6 more. Now once we have processed this particular row, we can move our current pointer again. So let me move our current pointer. Now we are going to point to the previous row, this particular row, the row index 1, or we can say the second row. It doesn't contain any security device, so no laser, right? So at this point, we can just take our current and previous indexes and move it above, right? So basically right now we have this as our current row, but since we do not have any previous row, we can stop here. So a simple way to solve it is just keep 2 pointers. We will have the current row and the previous row. That previous row, which is actually going to have a security device. If a row doesn't have a security device, we can just move our previous row counter above till we have a row which contains a security device. But if our previous row is pointing to -1, or basically a row which doesn't even exist, so in that case we can stop, because we don't have any row in which we are going to have any security device, right? So the solution for this will look very simple. We can have a variable called as result, which is initially 0. Then we can run a simple loop in the reverse order. Our loop is going to start from the last index and it is going to go till the index number 1. We don't need to process the index number 0, because this particular loop is actually tracking our current index. So if our current index is actually at this particular point, so it is not going to have any previous row which can contain the security device and the laser beams. So at this point we can stop. So we are going to run our loop from the last index to the second index, or basically the index number 1. So this is our loop for this. Now this is our current element or the current row. So I can say current is actually going to be equal to bank of I, that is the current row, dot count 1. This is going to count how many security devices are there in the current row. Now we are going to start initially as p equal to I minus 1. That's basically the previous row index. And then we are going to count how many security devices are there in the previous row, right? Bank of p dot count 1. Now there can be a condition that the previous row doesn't contain any security device. In that case, we need to move above, right? We need to move our previous pointer above. So for that, we can have a simple while loop, that while our current index, while our p, which is our previous index, that particular pointer is still more than or equal to 0, because we don't want to process the index number -1, and the value of previous is 0. That is, we do not have any security device in the previous row. So we are going to recalculate the value of the number of devices we have in the previous row, and then we can say p minus equal to 1. We can move our p pointer to previous index. This loop is going to run till we have a previous index which is more than equal to 0, and the number of devices in the previous row is 0. The moment we get a row which actually contains some devices, we are going to come out of the loop, and then we can do our counting, that the result is going to be equal to result plus current multiplied by previous. The number of devices in the current row and the number of devices in the previous row which actually contains some devices. And at any moment, if our previous index is equal to -1, so I think this should be p, not previous. If the p is equal to -1, we can directly return the value of result. You can even omit this particular step. It is not super compulsory. So now your solution looks more simple. Basically, you just need to count the number of devices in the current row and the previous row. And you need to count the previous row, which actually contains some device, till you have a previous row. And this is how you can actually count the number of laser beams. You have current multiplied by previous. And then finally, you can return the value of result. Submit this. This is going to pass all the test cases. So you can see we have a fairly good runtime and a fairly good memory usage. So we have solved this problem in a very efficient way. The time complexity of this would be O of n multiplied by m, where n is the number of rows you have and m is the length of any row. Basically, n is the number of rows, right? And m is the number of element in your rows, right? So that's the time complexity, and the space complexity would be O of 1. We are not using any extra space to solve the problem. So that's how we are solving this one. So guys, that's it for this video. If this video has helped you to understand something in this problem and solve it in an easy way, then make sure that you hit that like button. And if you are not subscribed to my channel as of now, then make sure that you do so. Subscribe to the channel, and I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.